All right, gosh, so we've graphed sine, cosine, tangent, right? We know what they look like. We graphed their reciprocals. What we have not graphed yet are the inverses. So a couple things. Remember properties of inverses in Algebra 2, and you guys saw them in this class too. So they're listed here for us. So number one, if we compose the two functions, okay, so if we take f of x and we compose it into its inverse, it should always equal x and only x. And if we take the inverse and compose it into the original, it should give us x and only x. Okay, so this is the composition piece. For 2, the domain of f is the range of its inverse, and the range of f is the domain of its inverse. Okay, so this is when we are talking about the x and y values switch, which means that their domain and range elements switch too. Okay, the third characteristic that we know about inverses is that when graphed, they're symmetric with respect to the line y equals x. This goes back to x and y values switching. They're symmetric across y equals x. And if a function has an inverse, the equation of the inverse has the x and y values switched, which means since we do use input-output, y is still our output, but we change the notation with the inverse of the -1. Here, I'll do an arrow. And x is still our input. Okay, that part gets a little bit tricky. So let's go back, let's review. We know that we can graph y equals the sine of x. And we used 4 tick marks for our period. Remember, the amplitude goes up to 1 and down to -1. And then we had pi over 2, pi, 3 pi over 2, and 2 pi, and then we had the negative also. Make sure you're using radians. Okay, we are not ever going to be using degrees. So then the sine, and if you need to, get out your unit circle, guys. The sine of 0 is 0. The sine of pi over 2 is 1. The sine of pi is 0. The sine of 3 pi over 2 is -1. And it oscillates back and forth. And then when we were to graph it, it just bounces back and forth between 1 and -1. We know that the domain of sine of x without transformations is all real numbers, and the range goes from -1 to 1. Okay, now, is this a 1-to-1 function? Basically, what that means is for every x, there's one and only one corresponding y, and for every y, there's one and only one corresponding x. Or does it pass the horizontal and vertical line test? And we say no, it does not. Yes, it's a function, it passes the vertical line test, but it is not 1-to-1 because it doesn't pass the horizontal. There are y's that correspond to numerous x values. Okay, so because our answer is no, and this is super important, we're gonna have to restrict the domain so that it can have an inverse function. And think about a parabola. If your original function is not 1-to-1, when you switch the x and y values, when you switch the x and y values, well, instead of your y's repeating, now your x's repeat, and you're no longer a function. So we have to restrict its domain. And think back to our unit circle. Okay, first quadrant, all trig functions are positive. Second quadrant, just sine and its reciprocal. Third, just tangent and its reciprocal. Fourth, just cosine and its reciprocal. So mathematicians had to decide. Well, we're definitely going to have the first quadrant for the restricted domain. But if I use the second quadrant, it's positive also. I won't ever generate my negative sign values, okay, because inverses are used to find the angle measure. And so I don't want that. So I need positive and negative values. So I cover the gamut, the whole range of possibilities. Well, then there's the third quadrant, but they're catty corner from each other, so that's weird. So then we're going to use for sine first and fourth quadrant. We'll go up and we'll go down. I don't want to use 0 to 90 and then nothing, nothing, and then 270 to 180. That doesn't make sense. There's a very large gap. So we say that the domain is restricted from negative pi over 2 to positive pi over 2, which means that I'm restricting down to negative pi over 2 and I'm restricting up to pi over 2. That's where that comes from. So for its inverse, we have f of x is equal to the inverse sine of x. Remember the properties we just talked about. Okay, your x and y values switch. So instead of going from -1 to 1 on my y-axis, I'm going to go from -1 to 1 on my x-axis. Okay, so I go to +1 and I go to -1. Instead of going from 0 to 2 pi and then 0 to -2 pi, I'm going to change my x-axis values to now be on my y-axis, all because of the properties and characteristics of inverse functions. But our domain is restricted on the original from negative pi over 2 to pi over 2. So for the inverse, I'm just graphing that portion. Okay, that's all we're going to graph because we restricted the domain on the original function. So I'm going to go up to pi over 2. Oh gosh, sorry. I know, some of you don't care about the color matters. Okay, so I'm going to go up to pi over 2, and I'm going to go down to negative pi over 2. What's halfway between 0 and pi over 2? Pi over 4. And then we're going to graph it backwards, just like we've done every other inverse function. If there is a coordinate at negative pi over 2, -1, that means that its inverse is going to have a coordinate at -1, negative pi over 2. Sine is 0, 0, right? So at 0 radians, we are 0. And then if there is a point at pi over 2, +1, that means I'm going to have a point at 1, pi over 2. And the one thing we're missing is what's happening in between, because we know that it curves. It's definitely not going to be, it's not going to be linear because this is not a linear function. But I do know that the sine of pi over 4 is rad 2 over 2, which is approximately, if we round, 0.7. So if the original sine function has a coordinate at pi over 4, 0.7, then its inverse is going to have a coordinate at 0.7 pi over 4. And the same can be said for negative pi over 4. Oopsies, I'm not approximating yet. Sorry, guys. Okay, so it would be negative rad 2 over 2, which is approximately negative 0.7. So if sine has a coordinate at negative pi over 4, negative 0.7, that means that we would have a coordinate at negative 0.7, negative pi over 4. And that will help us build our inverse function. Easy. Totally. Okay, so domain and range are switching between the original and the inverse. However, we did restrict it. Okay, so that means that the domain for our inverse sine goes from -1 to 1, and then the range is the restricted domain, this guy up here, so it's going to go from negative pi over 2 to positive pi over 2. Nice. Easy peasy, guys. You got this. Okay, but we've got cosine and tangent to cover also, so let's do it. Cosine oscillates between 1 and -1 also, and we went out 4 tick marks, so I'll do pi and 2 pi and get the negative version also, so negative pi and negative 2 pi. Again, if you need your unit circle out, get it out. You guys need to have been memorizing or memorized past tense, so refresh your memory here. At 0, cosine is 1. At pi over 2, it is 0. At pi, it is -1. 3 pi over 2, it is 0. And 2 pi, it is 1. And then I'm going to just keep repeating these points as I go back and forth. Okay, so our domain's similar to sine, which was really nice in the past. Yeah, the similarities is all real numbers. We know that the range is also -1 to 1 inclusive with the brackets. Now, is this function 1 to 1? And our answer is no, because again, the y values correspond to more than one x value. So if we were to take cosine as is and apply the characteristic where the x and y values switch for its inverse, it would not be a function because the domain and ranges switch. So the y values repeating here for the inverse would be the x values repeating, which means that it's not a function. So since our answer is no, we're going to have to restrict the domain so it can be an inverse function. Or you can think so that it can be 1 to 1 if that makes more sense to you. We can write that in here too, a couple different options, as long as we understand what it means. So universally, we are restricting the domain. All right, if we think about A, S, T, C, yes, the first quadrant's going to exist. But if we restrict it the same as we did with the sine function, ooh, yeah, cosine happens to be positive in the fourth quadrant also. So restricting it from 0 to pi over 2 and then 0 to negative pi over 2 only gives us positive values. We need to have both positive and negative. Well, in the second quadrant, cosine is negative. So we're going to restrict it to be between 0 and pi. Okay, this is all because we need to have both positive and negative values. So if I were to solve, I would get the full range of what cosine could be. All right, so we are restricting from 0 to pi for the cosine function. All right, what does it look like? F of x is equal to the inverse cosine of x. That means similar, x and y values switch. So instead of my y-axis going from 1 to -1, that's going to be my x-axis. And then look at where we've restricted. Yeah, I don't need to have any negative values here. I'm going to go from 0 to pi. All right, let's do it, guys. At 0, cosine is 1. So if I'm switching my x and y, that means that 1, 0 exists on my inverse function. If there is a point at pi over 2, 0, then that means that we have a coordinate at 0, pi over 2. And if there is a coordinate at pi, -1, that means then that we're going to have a coordinate at -1 pi. Because again, with inverse functions, your x and y values switch. Well, again, that can't be linear, right? No, it's not a linear function. We see that it oscillates. So let's use pi over 4. The cosine of pi over 4 is the same as sine rad 2 over 2, or approximately 0.7. So for cosine, if there's a coordinate, can you guys hear the rain? Sorry. If there's a coordinate at pi over 4, 0.7, that means we have a coordinate at 0.7 pi over 4. It is raining really hard, and in the room that I record, it's a sunroom, and so it definitely has an echo. I'm really sorry. Okay, so for the cosine of negative pi over 4, it is negative rad 2 over 2. So if there's a coordinate at negative pi over 4, negative rad 2 over 2, it would switch. So negative rad 2 over 2. Oh, we're not negative. Come on, Patterson. I'm in the land of sine. Come to cosine. Okay, so then we would be in the second quadrant, which is 3 pi over 4. My apologies, you guys. Okay, but it's still negative because we are in the second quadrant. So 3 pi over 4, and it would be right about there. So we can see that this is going to curve that way. Hopefully you graphed it better than me. Nice. Okay, so our domain, remember, the domain was restricted from the original, so our domain and ranges for the inverse will also be restricted. The domain is still going from -1 to 1 because that happens to be the range from the original. And the range is now this guy. So as we can see, we start at 0 and go to pi inclusive. Nice. All right, last but not least, tangent. Tangent was interesting because we had what? Yes, we had asymptotes. We had asymptotes because at certain locations, 0 was in our denominator. Tangent can be, there we go, sine over cosine, if we want to break it up with the ratios. Okay, so we saw that with our tangent graph. Let's go red. So where was tangent undefined? Ah, very good, at pi over 2 and at negative pi over 2. And then what's the period? Yes, good. It's going to be pi. So the asymptotes occur every pi units. The tangent of 0 was 0 at pi over 4. Tangent was 1 at negative pi over 4. Tangent was negative 1. So we know we don't cross the vertical asymptotes. We know that we can recreate the behavior of this function to recreate numerous periods of our tangent graph. For now, we'll only discuss period and amplitude with sine, cosine, tangent, and their reciprocals, cosecant, secant, and cotangent. Okay? Alrighty. All right, the domain. The domain was all real numbers, but we had to restrict it. And we saw that we would say that x can't be, and we always used the location of an asymptote. So for me, I'm going to say pi over 2 plus the period times k. Now the period is pi because it has not been transformed. This is the parent function. And we say where k is any integer. Because this is an infinite graph, we need to make sure that we account for everything. And then the range was all real numbers. Now, is this graph 1-to-1? No, it is not. And since our answer is no, yes, we have to restrict the domain again so that it can be 1-to-1. I like that better. Okay. A, S, T, C. Yes, we're going to use the first quadrant. Can we use the second? Oh, my pencil. No, because this has only sine functions. Oh, sorry, sine functions that is positive. So yes, we could. My apologies. Could we also use the fourth? Yes. So what mathematicians decided is that they were going to use the same as sine. And the reason being is because if you look at the graph, if we went from 0 to pi, the curves would not connect. We would have this. Oops, where'd my highlighter go? We would have this, and then we would have this portion down here. And we don't want that. Okay, so is there a way for me to read? Probably not. Okay, so we wanted it to be connected with the curve, and so that's why they used this guy right here. Okay, yes, they could have gone from 0 to 180 or 0 to pi, but then you wouldn't have had a connected curve, and so they chose not to. They chose to go from negative pi over 2 to pi over 2. All right, so here we go. What does it look like? It's f of x is equal to the inverse tangent of x. Okay, same idea. The x and y values switch because they are inverse functions. So my x-axis is going to go from -1 to 1. And my y-axis is going to go up to pi over 2 and down to negative pi over 2 because we restricted it as such. Okay, we restricted the original, so therefore our inverse is going to be restricted as well. Okay, we know that there are asymptotes at pi over 2 and negative pi over 2. So they're going to not be vertical asymptotes, they're going to be horizontal now, just like with exponential and logarithmic functions, yeah? Exponential functions, you had an asymptote that was horizontal. When we took its inverse, the log, then we found that their asymptotes were now, very good, vertical. Okay, same idea here. So on a tangent graph, you have vertical asymptotes. For its inverse, it's going to be horizontal. At 0, tangent is 0. At pi over 4, tangent is 1. So I'm going to go to 1, pi over 4. And then at negative pi over 4, it's negative 1. So negative 1, negative pi over 4. And I know that I'm going to get close to my asymptote. The function's going to curve, and then I'm going to get close to that asymptote as well. It's a little bit ugly. That's a little bit better. And now I just made it totally worse. Excellent. Okay. So our domain is, yes, it's going to be the same as the range of the original because we know that they switch. Okay, and then the range is simply going to go, yes, it is the restricted original domain. It's going to go from negative pi over 2 to pi over 2 non-inclusive. Good. So as we've gone through this, I've listed out some points that came from the originals, and then we switched the x and y values. I didn't always write them out. For tangent, if you'd like, we know that it is negative pi over 4 comma negative 1, and these are from the originals. Here, let's do this. There you go. So yes, you will be asked to transform, okay, and that's what you're going to see out in your homework. Transformations, don't get afraid, guys. It's the exact same thing. We take the reciprocal of b and multiply it times x plus or minus h, and then you take whatever a is and multiply it by y plus or minus k. Okay, that's still going to be shifting your function. So if you want specific points, because we've done that in the past, for the inverse tangent, the points that I would suggest that you use are negative 1, negative pi over 4, 0, 0, and then 1 pi over 4. Okay, if you want specific points for cosine, my recommendation would be, let's do it over here. Until we get comfortable with how the graph curves, I would say use negative 1 pi, use negative, where am I? 0.73 pi over 4. Okay, use 0 pi over 2. I would then use 0.7 pi over 4, and then I would use 1 comma 0. I know there's 5, I'm sorry, but until we get comfortable with how the graph curves, I feel like that's our best choice. And then for sine, I'll put him down here. So the inverse sine of x, I would use negative 1, negative pi over 2. And then, what is that? Negative 0.7, negative pi over 4. Move my screen. 0, 0. And then 0.7 pi over 4. And 1 pi over 2. Excellent. Your inverse functions, ladies and gentlemen. So remember, we do have to restrict the domain on the original because it was not one-to-one. I'm not going to do any transformations with you for these functions because we've transformed all year. I feel very confident you guys will be okay. I will post solutions for homework, and then if you have any questions, you know who to ask.